Hi, I'm Nuan from AWS.
And I'm Ben from AssemblyAI, and this is my architecture.
Ben, tell us a little bit about Assembly AI and type of challenges that you are solving with this architecture.
Yeah, at AssemblyAI, we're laser focused on developing ML models to understand human speech with superhuman ability. In a nutshell, we have a complete AI system for customers to get the most out of their audio data. The three challenges that we're trying to solve with this architecture are scalability, so handling millions of requests per day, ease of deployment and iteration, so developing new models quickly and updating existing models, and security and compliance, making sure we work with customers to meet their various compliance needs around the globe.
What kind of users interact with this system, and can you explain the user workflow here?
Yeah, all sorts of users interact with us via an API, whether it's podcast companies looking to understand the content on their platforms or telephony companies looking to evaluate and understand call center performance. It all starts with audio, though. So customers, Assembly AI users,
Mhm.
upload uh, their binary audio data to our API or submit a reference to that data from something like their own S3 bucket.
And then the flow continues from that ECS component that's the API manager, and then moves to the Amazon ECS here. Can you explain the flow a bit too?
Yeah, after we've validated the request and recorded what type of features they want,
Right.
we send that over to our orchestrator. This thing is the brain of the operation that really decides what models to call and in what order. After we've completed the request for the customer, we send a notification over SNS, which is subscribed to by a variety of services, one of which is this webhook Lambda.
Mhm.
This notifies customers in an asynchronous fashion that their transcription is completed.
I know there's this part of the architecture that we didn't talk about, and I assume the orchestrator here that you talked about delegates that task into the inferencing here. Talk us a little bit about what's happening here.
Yeah, well, the orchestrator, like I said, might be the brains of the operation. All the work gets done over here in this inference pipeline. We have dozens of models deployed. We're iterating on them constantly, so deploying new versions, new models, really laser focused on finding ways to deliver that value back to customers. So this orchestrator sends messages into SQS, which drives our actual models running on ECS to scale up and down and to perform inference on that data.
Okay. How do you use S3 in this architecture?
Yeah, so audio data, as you can imagine, is pretty big. So we actually pass it by reference from S3 into the ECS container. After a customer has submitted their data to our API, we download it, transcode it, and then it actually gets stored over here in S3.
S3, I see. So you explained like you're using SQS and you're building like a queue and the jobs are getting submitted. What kind of speed are we talking about?
Yeah, so we really tried to keep the queue empty. This is an asynchronous system, so we've created this custom scaling loop here. It does a couple of things. It watches the depth of the queue, as well as predicting when a model is going to get called and being able to scale it up in time. So a great example of that would be a customer requesting speaker labeling. So who's talking and when. We know that that comes after converting audio into text. So we can pre-scale that service such that the capacity is there right when we need it.
Tell us a little bit about the ML models you use in this architecture.
Yeah, so most requests start with our flagship speech-to-text model. It's called Conformer 2. This takes that audio binary data and converts it into text. From there, we can send it to a variety of different models based on the customer's use case. So speaker labeling, like I mentioned, sentiment analysis, what's the mood of the conversation, and even into things like LLMs, where customers can ask questions about their audio data.
You briefly touched upon the scalability aspect. Tell us a little bit about when those requests comes in. How do you scale this pipeline over here?
Yeah, so requests are coming in all the time, millions per day, and we're recording that in CloudWatch. And we know, based on the decision engine inside our orchestrator, which model and in what order they're going to be called. So using signals like queue depth and our custom scaling, we can provision more containers for more models. So popular models are going to be scaling up and down more quickly than less popular ones, as an example. In general, these models are pretty expensive running on GPU, so we really like to have good scaling to control cost.
Tell us a little bit about security. How did you handle security in this architecture?
So there's a lot of non-functional requirements, compliance, things like that we provide for our customers. We're SOC 2 Type 2 certified and really care about following best practices for storing data. We have strict lifecycle policies over here in Amazon S3, so we keep the data only as long as it's useful for our orchestrator and for our ML pipeline.
That's awesome, Ben. Thank you so much for explaining this architecture to us. I really enjoyed the conversation.